Cambridge Primary Science. Monday the 21st of March 2022. 3. Material changes. 3.1 Reversible and irreversible changes. Reversible changes. Activity 3.1. Observing changes to ice. Place the ice cubes in the sun or other warm place. For 5 minutes. What has happened to the ice after 5 minutes? What causes the ice to change? What will happen to the ice if you put it back in the freezer? Why? Words to learn: reversible, irreversible. You will need ice cubes, saucer, black circle, watch. In a warm place, the solid ice becomes liquid water. When you put the ice back in the freezer, it becomes a solid again. We say that the changes are reversible because we can change solid ice back to liquid water and liquid water back to solid ice. Heat causes the ice to melt. When the water loses heat and cools, it becomes solid again. This diagram shows phase changes between ice and water. Irreversible changes. When some substances are heated, the changes cannot be reversed. We call these irreversible changes. Sometimes irreversible changes turn one substance into another substance. For example, when we burn a match, the wood changes into a black substance called carbon. What happens when we burn a match? Can the match change back to the way it was? Questions. W for the 22nd of March 2022. 1. When you mix boiling water with jelly powder. 2. The mixture is a liquid. In the fridge it becomes solid. Can we make jelly change back to a liquid? Draw a simple flow diagram to explain your answer. A. Does boiling an egg cause a reversible or irreversible change? Explain why. B. Does a new substance form when you boil? Dear glass bottles and JORS. Glass can be collected in recycling centers and used again. 2. Are irreversible because it cannot be back to what it was before. An egg. 2b. Yes, the heat taken in the egg causes an irreversible change. 3. Think of an irreversible change that forms a new substance. 3. Irreversible change. Combustion forms carbon dioxide, burning of wood, chopping of wood, baking cookies, boiling egg, frying potato, burning paper, metal rusting. What you have learnt. Heat makes substances change. Some changes are reversible, for example, ice melting and refreezing. Some changes are irreversible, for example, burning a match. Some changes cause a new substance to form. How is glass recycled? To form new glass products. 3.2 Mixing and separating solids. Words to learn: mixture. What is a mixture? A mixture is made up of two or more different substances mixed together. The substances in a mixture are not chemically joined, and so we can separate them. Mixtures can be solids, liquids, or gases. Air is mixture of three main gases: nitrogen, oxygen, and carbon dioxide. Think of some other mixtures. Activity 3.2. Making mixtures of solids. Make the following mixtures in separate jars: rice and flour, salt and sand, tea leaves and sugar, beans and marbles. Stir each mixture well. Observe the mixtures. Can you see the different substances in each mixture? Have the substances in each mixture changed in any way? Separate, react, sieve, sort. You will need rice, flour, salt, black circle, sand, tea leaves, sugar, beans, marbles, glass jars, spoons. Rice, salt, and tea leaves and beans and flour, sand, sugar, marbles. The substances in a mixture do not change when they are mixed together. We say that they do not react with each other. Separating mixtures. We can separate the substances in mixtures in different ways. If you pick out the nuts in a mixture of nuts and raisins, then you sort the mixture. Gardeners use a sieve to separate stones from the soil. Activity 3.2b. Investigating separating mixtures of solids. Select a method to separate each of the mixtures. You can choose sieving or sorting. Separate the mixtures. HW the 23rd of March 2022 P45 Q1, 2, 3. Questions. Were there? U. Peanuts and raisins are a mixture of solids. If you don't like raisins, you can pick out the nuts. You will need the mixtures from Activity 3.2, a black circle sieve, glass jars bowl. Any mixtures could not separate? If so, why did this happen? 2. Which method is best for separating mixtures that contain a large particles that you can see easily? B. Small particles that you cannot see easily? U. Think. 3. Predict, with reasons, which method of separation is best for separating mixtures of A. Peanuts and beans. B. Salt and breadcrumbs. C. Peas and flour. What you have learnt. A mixture is made up of two or more different substances mixed together. Talk about it. How can scrap yards separate iron from a mixture of different scrap metals? The substances in a mixture do not react with one another. Some solids can be mixed and separated again by sorting and sieving. 3. Material changes. 4. 3.3 Soluble and insoluble substances. Some solids like sugar can dissolve in a liquid. Sugar can dissolve in water. It is called a soluble. Words to learn. Dissolve. Soluble. Insoluble. Suspension. Substance. Some solids do not dissolve in a liquid. Sand does not dissolve in water. We say it is insoluble in water. Activity 3.3. Investigating soluble and insoluble substances. Look at all the solids that your teacher provided. Predict which substances will be soluble in water. Write down your predictions in a table like this. What happens to the sugar that we stir into our tea? You will need measuring cylinder, glass jars, teaspoon, clean water, different solids, substance, prediction, soluble or insoluble, observation, clear or cloudy, conclusion, soluble or insoluble. Measure 100 milliliters of water into each jar. Add 1 teaspoon of solid to each jar. Stir the water and observe what happens. Are the mixtures clear or cloudy? You still see the solid substance? Can record your observations and conclusions in the table. Leave the mixtures for 5 minutes and observe them again. Questions. 1. What happened to the solids in the cloudy mixtures? B. What happened to the solids in the clear mixtures? 2. What happened to the mixtures after 5 minutes? B. Why do you think this happened? 3. Which substances dissolved in the water? Were your predictions correct? 4. Why is it important to use the same amount of water and solid in every case? When you mix insoluble solids in a liquid, you can still see the solid. An insoluble solid forms a suspension in a liquid. Soluble substances mix completely with the liquid so that you cannot see them. What you have learned. Substances that dissolve in liquids are soluble. Substances that do not dissolve in liquids are insoluble. Soluble substances mix completely with the liquid so that you cannot see them. Insoluble substances do not mix with the liquid and form a suspension. Talk about it. Why do lumps of sugar dissolve slower than grains of sugar? 3.4 Separating insoluble substances. What is filtering? Filtering is a method used to separate mixtures of a solid and liquid. A filter works like a sieve. A filter separates soluble and insoluble substances. It has tiny holes that let through very small particles but not bigger particles. The liquid and the soluble substances dissolved in the liquid pass through the holes. Insoluble solid particles are too big to pass through and stay behind. For example, the filter paper in a coffee pot lets the water through but not the grains of coffee. Sand filters use layers of gravel and fine sand to separate particles of solids from water. In nature, wetlands such as marshes and swamps act as filters. As water passes through the wetland, it slows down. The soil and gravel of the wetland filter out particles of different substances from the water. Some of these substances may be harmful, for example chemicals and human body wastes. The wetland makes the water cleaner. Words to learn: filtering, filter, wetland. Wetlands filter water to make it cleaner. Activity 3.4. Separating mixtures by filtering. Measure 100 milliliters of water into each jar. Stir 1 teaspoon of solid into each jar. Use the filter funnel and filter paper to filter each mixture into another jar. Questions. 1. What was left behind on the filter paper after you filtered each mixture? 2. What went through the filter paper into the container? Why did this happen? 3. Can you separate the solid and liquid in a solution by filtering? Say why or why not. 4. Predict the results you would obtain if you filter a mixture of flour and water. B. Give a reason for your prediction. Flamingos and many other birds have filters in their beaks. They catch food, like algae and small fish, by filtering the water. You will need sand, water, chalk, filter paper, filter funnel, jars or beakers, measuring cylinder, black circle, spoon. Challenge: design a method to separate a mixture of sand and salt. What you have learned: filtering separates insoluble solids from liquids. In mixtures. In a filter, very small particles pass through tiny holes in the filter, but bigger particles cannot pass through. Talk about it. How does a tea bag let the flavor and color of the tea through, but keep the tea leaves behind? 3.5 Solutions. You have found out that some substances can dissolve in water or other liquids. These substances are soluble. A soluble substance forms a solution with a liquid. Solutions always have two parts. The substance that dissolves, called the solute; the liquid in which the solute dissolves, called the solvent. Look at the picture of seawater. Can you see the salt in the water? How do you know the water contains salt if you can't see it? Seawater is a solution. The salt dissolves in the water to make the solution. The salt is the solute and the water is the solvent. Words to learn: solution, solute, solvent, uniform. Activity 3.5. Making a solution. Pour 100 milliliters of water into the jar. Put a teaspoon of crystals into the jar and observe. What happens? What can you observe in the water around the crystals? Draw and label your observations. Wait 5 minutes. Can you see the solid crystals anymore? In this activity, which is the solute and which is the solvent? You will need water-colored crystals, glass jar, teaspoon, measuring cylinder, black circle, watch. Cool. Drink. The particles of the solute move between the solvent particles when they dissolve. Because of this, you cannot see the solute in a solution after it has dissolved. We say that a solution has a uniform appearance. It looks the same throughout. Mixtures and pure substances. Mixtures are made of particles of different substances. We can separate most mixtures because the particles of the substances in the mixture are not chemically joined together. A pure substance consists only of particles of that substance. The particles in pure substances are chemically joined together and cannot be separated. Powder for a cool drink is a mixture. It is made of particles of sugar and other substances. Questions. Solute particles spread out evenly in the solvent. Sugar is a pure substance. It is made only of particles of sugar. 1. Is a solution a mixture or a pure substance? Discuss this question and make a prediction about the answer. 2. What evidence do you need to collect to investigate the question and why? 3. How could you make sure you collect enough evidence? 4. What equipment and methods would you use? 5. How would you make your test a fair test? What you have learned. A solution is made up of a solute dissolved in a solvent. Mixtures are made of particles of different substances. Pure substances consist only of particles of that substance. Talk about it. Is the juice of an orange a mixture, solution, or a pure substance? Most mixtures can be separated, but pure substances cannot be separated. 3.6 How can we make solids dissolve faster? Did you forget who to put sugar in my coffee? It's not sweet. Words to learn. Rate. Conclude. I put in 2 teaspoons like I always do. Why do you think the coffee tasted bitter? How could the boy make the coffee taste sweeter without adding any more sugar? The coffee and sugar form a solution. The sugar will dissolve faster if the boy stirs the solution. Stirring is one way to make solid solutes dissolve faster. Stirring causes the particles of the solute to spread out into the spaces between the particles of the solvent more quickly. We say that stirring increases the rate at which a solute dissolves. Solute. Solvent. Dissolving. When a solute dissolves, the particles spread out through the solvent. This happens more quickly if you stir. There are other factors that make solids dissolve faster. Have you ever tried to make coffee with water from the fridge? Why do we use hot water? Activity 3.6. Does sugar dissolve more quickly in hot or cold water? Does sugar dissolve more quickly in hot or cold water? Make a prediction. You will need sugar glass jars, cold water, hot water, teaspoon measuring cylinder, stopwatch. Stir a teaspoon of sugar into 100 milliliters of cold water in a glass jar. Stir a teaspoon of sugar into 100 milliliters of hot water in a glass jar. Time how long it takes for the sugar to dissolve in both jars. Record your results in a table. Questions. 1. In which jar did the sugar dissolve quickest? Suggest a reason for this. B. Was your prediction correct? 2. How did you make sure that your test was fair? 3. Write down what you conclude about the effect of temperature on dissolving a solute. The particles in matter are always moving. When we increase the temperature of a substance, the heat adds energy to the particles of the substance. This energy causes them to move faster. In a heated solvent, the particles of the solute move faster than in a cooler solvent. This allows the particles of the solute to spread through the solution more easily, so the solute dissolves faster. What you have learnt. Stirring a solution makes solid solutes dissolve faster. This is because the particles of solute spread. Talk about it. Do all solutes dissolve faster in hot water? Out into the spaces between the particles of the solvent more quickly. Heating a solution makes solid solutes dissolve faster. This is because heat speeds up the particles and allows the solute to spread through the solution more easily. 3.7 How does grain size affect dissolving? Did you forget to put sugar in my coffee? I've stirred it, but it's still not sweet. Prediction. Small grains dissolve faster. Activity 3.7. Does grain size affect the rate of dissolving? Do large grains dissolve faster than small grains? Write down a prediction. Plan and conduct an investigation. To find out, make a list of all the materials and equipment you need. Identify the factors you are going to change. List all the factors that you are going to keep the same. Write down a method that you can follow to carry out a fair test. Record your results in a table. Draw a bar chart of your results. Coarse salt with large grains. 6. 3 material changes. No granny, I put in 2 lumps of sugar. Fine salt with small grains. 1. The evidence supports the prediction. The small grains dissolved faster. 2. Conclusion. Small grains dissolve faster than large grains. Questions. 4. The grains. 1. Does the evidence you obtain support your prediction? How would dissolve? 2. What conclusion can you draw from your results? 3. Suggest a way to check if your conclusion is correct. Faster if a fine powder, small grains, was used. 4. Predict how the time taken for the grains to dissolve would change if you used a fine powder. 3. Repeat the investigation a few times with different sized grains of other substances. The grain size of a solute affects the rate at which it will dissolve in a liquid. Each small grain is made of fewer particles than each large grain. The particles on the outside of the grain dissolve first because they are in contact with the liquid. When they dissolve, other particles in the grain come in contact with the liquid and dissolve. In large grains with lots of particles, it takes longer for all the particles to come into contact with the liquid and dissolve. Rainwater can dissolve some types of rock. When the rainwater falls through a cave, some of the rock particles can come out of the solution, forming dripstones like these. Ones like the what you have learned: the grain size of a solute affects the rate at which it will dissolve in a liquid. Small grains dissolve faster than large grains. Talk about it. Why do you think we dissolve some medicines, such as aspirin tablets? 3. Check your progress. 1. Sunil made popcorn. He heated oil in a cooking pot and put in the popcorn kernels. A minute later they popped to make popcorn. 1. A. Irreversible. Popcorn cannot change back to its original form. 1. B. Heat. 1. C. No. It is still a popcorn but in a different form. A. Is this a reversible or irreversible change? Say why. B. What makes the popcorn kernels change? C. Did a new substance form? Say why or why not. D. Draw a flow diagram to show the change in the popcorn. 2. These are pictures of mixtures. A. Salt and water. B. Sand and water. C. Flour and water. D. Beans and water. A. Which substances in the mixtures are soluble and which are insoluble? B. Which mixture is a solution? How do you know this? C. Which mixture is a suspension? How do you know this? D. How can you separate mixture B? D. Filtering. E. Name 2 ways you can separate mixture D. E. Sieving and sorting. 2a. Soluble mixtures. Salt and water. Insoluble mixtures. Beans and water, sand and water, flour and water. 2b. Solution. Salt and water. The solid cannot be seen anymore and the mixture is clear. 56. C. B and C and D. The solid can be seen and the mixture of water and flour is oody. And the sand has sunk to the bottom and can still be seen. 3. Material changes. 3. When you make jelly, you mix jelly powder with water to make a solution. Water. 3. Jelly powder. A. Name the solute in the jelly solution. A. Solute. Jelly powder. B. Name the solvent in the jelly solution. B. Solvent. Water. C. Make a drawing to show the dissolved particles in the jelly solution. D. Name 2 factors that affect the rate of dissolving when you make jelly. D. Stirring, temperature. Arrange the steps of an investigation in the correct order. Write the letter of the sentences A, G in the correct order. A. I have learned that sand cannot dissolve in water. B. I put 1 teaspoonful of sand into the water and stirred it. C. I poured some water into the jar. D. I decided which materials and equipment I needed for my experiment. E. After 10 minutes, the sand formed a layer at the bottom of the bottle. F. I asked the question, how can I find out if sand dissolves in water? G. I found a glass jar, a teaspoon and a cup of sand.